Hello students, welcome to Unit 9 Notes Section 10.4. This is the last section that we have for our notes, and I'm expecting it to go by pretty fast. If you can do me a favor and do the perimeter of each one of these figures I wrote down. In terms of area, I'll write that down as well. I just wanted to pause so that you could see the perimeter parts for 1, 2, and 3. And the area, because it's going to get a little bit, it's going to fill up with space here. So 7 times 7 is going to be 49 inches squared. Area for this one is going to be 8 times 4, which is 8, 16, 32 meters squared. And this last one is going to be half of 8 times 6. 6 times 8 is 48, so half of that is 6 times 8 is 48, so half of that is 24. Okay, so you can feel free to pause it at this time. And, oh wait, I'm sorry, I meant to do the perimeter, the area of these. So area for these, 1 times 3 is 3. Um, 6 times 2 is 12, so area is 12 centimeters squared. And area here, 9 times 3 is 27 centimeters squared. All right. So the last part of this is doing a comparison between perimeters and areas. What's really cool about perimeter and area is that perimeter is a linear distance and area is in a unit of measure that's in squares. So here we have some listings. So the ratio of perimeters, if one figure to another is A to B, then the perimeters are A to B. So let's say you're given one length of a trapezoid. Okay, so let's say I'm given that the length of a trapezoid is 5 centimeters. And the length of another side of the same side that corresponds to it is 7 in another trapezoid. Then the perimeters are also 5 to 7. So that means that we'll do an example or two, okay? But here, its area, what you're going to do is square it. So if it's in relationship 5 to 7, then this would be a 5 to 7 relationship as well. And then this would be 25 to 49, because you would square the 5 and square the 7. So again, if it has a leg that's 5 and a leg that's 7, and they correspond, then their perimeters are 5 to 7 as well, collectively, totally, whatever they might be. It might be 25, 35, 45, and then whatever other number corresponds with it would correspond with it. And then the ratio of their areas is going to be the squared of their units. Okay? So let's do the first one. So here we have two trapezoids. You see 1, 6, 1's 9. We don't know anything about anything else. We don't know what that is, that is, that is, that or that, or its area, but we don't need to know any of that. We know how they correspond, and we know what their ratios are. So the trapezoid at the right are similar. That's the most important part, the word similar. If they're similar, then we can keep going forward with doing what we're doing. That means that they are enlargements or reductions of each other. They are not exact, but they're enlargements or reductions. So the ratio of the lengths of the corresponding sides is 6 to 9, which we see here, 6 to 9, or what we always want to try to do is reduce it, so 2 to 3. It's a 2 to 3 ratio. So find the ratio smaller to larger of the perimeters. Well, the perimeters are also going to be 6 to 9. So we can write it 6 to 9, which is going to be, so we're not going to write it that way, but we're going to say it's a 2 to 3 ratio, or we can say 2 to 3 ratio this way. Here, let me get rid of 6 to 9. So we can write 2 to 3. We can write or, we can write 2 to 3 that way, or we can write 2 to 3 with a colon. Okay? Now, what are the ratios smaller to larger of the areas? So it's going to be 2 squared, it's going to be 2 over 3 squared, which is 4 to 9. Or we could say 4 to 9 like this, or we could say 4 to 9 like this. So any one of those are correct. All right. So it's really cool. The areas don't exactly correspond the exact way that the perimeters do because they have to be squared units. All right, two smaller polygons have corresponding sides in the ratio of 5 to 7. Find the ratio of their perimeters. 5 to 7. That was easy. So I'll write, you know what, I'll write all options. 5 to 7 like that, or 5 to 7 like this, or 5 to 7 like that. So what's the ratio of their perimeters? Let me just change these different colors so they stand out. So it's not going to be 5 to 7, but it's going to be 5 squared. So it's going to be 5 squared. And 7 squared. It's going to be equal to 25 to 49, or, yep, so let me erase all this because it's not working out the way I thought it was going to with spacing. So or 25 to 49 this way, or 25 to 49 this way. Okay? So again, you want to take your simplest form. So simplify it down, which it is 5 to 7, and then square each one of those. All right. So the area of the smaller rectangular pentagon is about 27.5 centimeters squared. I'm sorry, regular, not, I don't know what I just said. Smaller regular pentagon, it's about 27.5 centimeters squared. What is the best approximation for the area of the larger one? So here's what we're going to do. We're given its perimeter. And that's not exactly what's going to help us. What we're going to have to do is say we have 27.5 centimeters squared. We want to know the length, the area of the larger one. Well, these are not centimeters squared, they're centimeters. So we need to make them centimeters squared. So we're going to do 4 centimeters and we're going to square it. And then we're going to do 10 centimeters and we're going to square it. So what's cool is that you don't have much work to do. What you have to do is do 4 squared and 10 squared, because you have to bring these units into the squared format because you're comparing the areas of them, which is going to be 16 to 100. And those areas compare because it's for every 16 squared units here, you have 100 squared units here. Well, what if I have 27.5 square units? Well, it's not going to be 100 or it could be more than 100, okay? So that's what we're trying to determine now. So we are going to write this now as 16 over 100. We're going to forget units for a moment, equals 27.5 over x. So what you notice is that I did not square 27.5 because those units were already squared. But I had to square the perimeter units to get them into a form of an area unit to make them comparable to one another. So now I'm going to do my cross products, okay? So I get 16x equals 275. Now I need to divide both sides by 16. So x approximately equals, it is not, this pencil is not working today. Okay, x approximately equals, there we go, 275 divided by 16, which is about 17.2. I got 1875. 17.2. The units I solved for are being squared, so it's going to be centimeters squared. So 17.2. The area, what did I do wrong? Hold on. Whoops. 100 times 27.5. I thought it was 2.75 times 27. We're going to add a 0 here. Yep. 27.5 times 100 is 2,750. My apology. Divided by 16 is 170. Let me times this by another 10. 171.875. So 171.9. And going back here, that's about 172. All right. Sorry about that. I was off by a 0. So the corresponding sides of two similar parallelograms are in the ratio of 3 to 4. So again, this was sides. So these are, that's your key word. It's not area. Okay. So the area of the larger parallelogram is 96. Find the area of the smaller. So here we have 3 is to 4. That's smaller is to larger. So we're going to square smaller is to larger as smaller is to larger. Now, why did I square those? Well, let me rewrite it and I'll erase what's above because it's 3. You know what? It doesn't even list inches as the unit, but we know that's going to be 3 inches. It says 3 to 4. It really could be anything though. So let's just leave our units off. We know that whatever units they are, if it's 3 to 4, if it's 6 to 8, 9 to 12, whatever that combination might be, it's been reduced to 3 to 4. And the area of the larger is 96. So what we need to do is this is area. That's already been area because inches squared, and now this is turning into an area because I am squaring it. So let me get rid of all those arrows. Okay, so we have 9 is to 16 as x is to 96. So now I'm going to find the cross products, and I get 16x equals 9 times 96, which is 864. So now I'm going to divide both sides by 16. I get x equals 54, and my unit of measure is inches squared. And I'm done. So the area of the smaller figure is 54 inches squared. The area of the larger, parallelogram is 96 inches squared, and the ratio of the side lengths are 3 to 4. The length of the perimeters are in a ratio of 3 to 4 as well. Okay. And now the next one. During the summer, a group of high school students used a plot of city land to harvested 13 bushels of vegetables that they gave to a food pantry. Their project was so successful, the next summer the city will let them use a larger similar plot of land. Again, that word similar is there. That's the most important part of this whole lesson. As long as they're similar, it all works out. Okay? And the new plot dimension, each dimension is 2.5 times the corresponding dimension of the original plot. How many bushels can they expect to harvest next year? So it looks like they use a plot of city land. Let me just give me 1 second. Of city land and harvested 13 bushels of vegetables that they gave to a local food pantry. The project was so successful that next summer the city will let them use a larger similar plot of land. In the new plot, each dimension is 2.5 times the corresponding dimension of the original plot. How many bushels can they expect to harvest? Okay, so in their original plot of land, let's just call it a square. It doesn't really matter here what they were given. But they were given something that was one side by one side. Okay, so that could be 12, that could be whatever. It doesn't really matter. What we do know is that enlarged to the point where it was 2.5 times the size. So let's say 2.5x and 2.5x, because I don't know what x is. Or what, I mean, I could call it x and y, but I'm just gonna call it that right there. It grew 2.5 in both directions. So what we want to do is 1 times 1 is 1. What's 2.5 times 2.5? And that's what we want to do. So 2.5 times 2.5 is equal to 6.25. So in the original case, this gave us it gave us how many? 13 bushels of vegetables. So this plot of land gave us 13. Regardless of if it's x and x or if it's x and y, or x and z or whatever variables you want to use, you're going to expand both directions by 2.5, making it 2.5 times 2.5 wider, making it 2.5 times 2.5, which is 6.25. So what we need to do now is multiply 13 by 6.25. So times 13, that's how much larger it is. It's not 2.5 larger, but it's 2.5 and 2.5. So we are actually going to get the number 81.25. So it's 81.25 bushels. So the students should be able to do 81.25 bushels. bushels. And the only reason is because regardless, again, let's say it was 1 foot by 2 feet. Well, now it's 2.5 by 5 feet. So 1 by 2 is 2. Okay, 2.5 by 5 is 12.5. So again, it would be increasing 1 by 2, and then 2.5 by 5 divided by 2. Yeah, 6.25. It would still be increasing by 6.25. Okay. All right. The similarity ratio of the dimensions of two similar pieces of window glass is 3 to 5. The smaller piece costs $250. What should the cost of the larger piece be? So this is the similarity ratio of the dimensions of two similar pieces of window glass is 3 to 5. So this is already accounted for its area. It's just going to be a 2 to 5 is equal to, two similar pieces is 3 to 5. I'm sorry, it was 3 to 5. The smaller piece is $2.50. X is going to be represented in money, and we're just going to do the cross products. So 3x equals 12.5, right? Because, wait a minute, 5 times 2.5, 5 times 2.5, yep, it's 12.5. So I'm going to divide it by 3. So x approximately equals, this is cost per piece, is $4.17. The similarity ratio of the dimensions of two similar pieces of window glass is 3 to 5. The smaller piece costs $2.50. What should the cost of the larger piece be? Yep, $4.17. All right. This last one is crucial. So we're one slide away from being done. And this is crucial because this is what a lot of your IXL assignments will turn into. They're not going to be straightforward as like 1 to 2 or 1 to 3 or 1 to 4. It might say 2 to 8. So what you have to do first is simplify it. Get it down from 2 to 8 to be 1 to 4. And then you can do the work that you need to. So the areas of two similar triangles are 50 centimeters squared and 98 centimeters squared. What is the similarity ratio? What is the ratio of their perimeters? So when it's 50 to 98, let's write that out. So 50 centimeters squared to 98 centimeters squared. That's not their ratio. Let's divide out the centimeters from both sides first, and then let's divide it by 2. So 25 to 49. So now your ratio, oh, give me a second. So divide out the centimeters, then divide it by 2, and you get 25 to 49. This is what we call the similarity ratio of its area. It's not 50 to 98. I mean, it is, but at the same time, we want it to be in reduced form. So similarity ratio your similarity ratio is 25 to 49. Now, what's the ratio of its perimeters? This is really cool. Watch this. The ratio of perimeters. So the ratio of your perimeters is not 25 to 49. It's the square root of 25 and the square root of 49. Why the square root? Well, think about the way to get from a perimeter to an area is to go from linear to squared, from a linear distance to a squared unit of measure. So we're multiplying by the same amount or some type of other amount that makes a squared unit. So now to get from perimeter to area, we have to find the square root of, from area to perimeter, instead of squaring it, we have to find the square root. So the ratio of perimeters is going to be 5 to 7. So perimeter ratio is 5 to 7. And we're done. So again, it wouldn't have worked well if I just try to find the square root of 50 and the square root of 98. I'm going to be in a crazy, crazy spot. It's not nice numbers. It's a little bit more than 7, and it's a little bit less than 10. Not good. But find half of it, and then you can find the square root. So simplify square root, and then you're good. All right, the areas of two similar rectangles are 1875 and 135. Find the ratio of their perimeters. So this last one, we have 1875 feet squared is to 135 feet squared. These are the ratio of their areas. So let me see what they both have in common. So 135, well, let's see, 1875 divided by 135. Yep, that doesn't work out. So 1875 divided by 5. So I'm going to slowly find, try to simplify it. So 1875 divided by, whoops, my bad. Divided by 5. Whoops, I keep timesing it. 1875 divided by 5 is 375. So 375 feet squared is to 135 divided by 5, which is 27 feet squared. And I'm going to take a look to see if they both have a 3 in common. Oh, they do. So divided by 3 is going to be 125 feet squared to 9 feet squared. Okay, now I can't go any more simple. So this is the area ratio. Now perimeter ratio, we're going to find the square root of it. Let's see. I wonder if I made a mistake when I typed this question out. 1875 to 135. 1875 divided by 135. Guess I didn't. All right, so the perimeter ratio is going to be the square root of 125, and it's going to be the square root of 9. So that is going to be square root of 125. You're going to have to use your factor tree, but it comes out to the square root of 25 times the square root of 3, right? Square root of 25, oh, I'm sorry, times 5, my apologies. So we get 5 square roots of 5 is to 3. I don't like that as an answer. So, because you don't normally have a radical on one side. So we're going to square this, and we're going to square this, and we'll fix it. So 25 square roots of 25 is to 9, and that's 25. So this is 125. We don't want to square it. All right, I think we're good with this one. I might have made a mistake when I typed out the answer. I think that's pretty good for this answer. 10-4. Let me check the textbook real quick and make sure I got that question right when I typed it out. Book resources. All right, 10-1, 10-2, 10-3, 10-4. Ten three, 10-4. Okay, I'm on 10-4. It says it's number 4. 1875 and 135 feet squared. They're both feet squared. Find the area. Okay, those are the areas. Find the perimeter of their ratios. Okay, so let me see if I made a mathematical error. So 1875 and 135 were correct. So 1875 divided by 5 divided by 5. So it's divided by 25. Oh wait, I can't do 135 divided by 25. So 135 divided by 5 divided by 3. So divide that one by 15. 1875 divided by 15 is 125. Surprised this problem doesn't work out well. So we will leave the area ratio the way it is, and it's going to stay that way. It's not wrong. Most of the time, you want to leave it in simplest radical form, and we just won't be able to with this problem. So you'll notice on your IXL assignments, they'll all be perfect in simplest radical form. Here we'll have to leave it as the square root of 125 to the square root of 9, which is going to be 125 divided by 5 divided by 5. Yep, so I'll leave it as 5 square roots of 5 is to 3. We will leave that as the final answer for the perimeter ratio. Yep, sorry about that. I just was not expecting it to be in a radical. Oops, all right. So you can do these problems and then make sure you do the IXL assignments. I think there's 4 this time around for the whole week. Okay, good luck.